Hey, so we just made the unit circle, and it's like, oh, great. We can find pretty much any trig function that we want to, and of sine and cosine. We talked a little bit about that in class. I'll talk more about that later. But what I want you guys to know about now is like, well, there's actually a way of finding any trig function with any point, not just the special ones that we found. And this right here, this table explaining, hey, what sine of theta is going to be equal to for any point. Again, sine of theta for any point x comma y. So any point that I have, I know that sine is going to be y comma r. But wait, where did r come from? R is going to be the like a radius that I find. And I know this is kind of confusing just to be, bam, here it is. It'll make more sense with an example. But what we have to know is these here. And if you notice something, okay, again, what you talked about this, what I showed it out, is that really you just need to know sine, cosine, and tangent. Sine you need to know as y over r, cosine is x over r, and tangent as y over x. Why? Because cosecant, secant, and cotangent are just the reciprocals of all of those. Okay? Y'all ready? Let's see an example so we can see how this is used. So, first example. It says here, let negative 4 comma 3 be a point on the terminal side of an angle theta in standard position. All right. So let's see here if I can just here and this here, and I'm going to draw the point negative 4 comma 3. Here we are, negative 4 comma 3. It's up here. Draw the point negative 4 comma 3. So what's going to be my standard position, the terminal side? Well, it's just a point. Well, where's my terminal side? Here's my terminal side, standard position. Here is my angle. This is my angle theta. Okay, oops. Not theta. And then I want to say find the exact values of the 6 trigonometric functions of angle theta in a standard position. Okay, great. So yeah, that's my angle theta. Well, how can I find this? Well, I need to find this distance here. This distance here, that's r. Well, how can I find that? Glad you asked. Again, take a look. Here's 3. That distance is a negative 4. And yes, it's okay to be a negative 4 there. Okay. That distance is negative 4. We're going to pretend it's okay for distance to be negative 4. All right. And I find out what r is going to equal. R is equal to, hey, Pythagorean theorem. A squared plus b squared is equal to c squared, right? Okay, so r squared is equal to 3 squared plus a negative 4 squared. So r is equal to the square root of 9 plus 16, which is equal to the square root of 25. Or r is just equal to 5. Okay, well, r is just equal to 5. Great. So when r is equal to 5, now I have the information I need to get my 6 trigonometric functions. I'm able to say that sine of theta is equal to y over r. My y value was 3. My r value is 5. My cosine of theta is equal to x over r. My x value was a negative 4. My r was a 5. Tangent of theta was equal to sine over cosine, which is y over x. Okay. And that's going to be equal to 3 over negative 4, which is equal to a negative 3/4. Okay. What about the other ones? Well, the other ones are just reciprocals. Cosecant of theta is the reciprocal of sine theta, so that's just 5/3. Secant of theta is just the reciprocal of cosine, or a -5/4. And finally, cotangent of theta is just the reciprocal of tangent, which would be a -4/3. That's it. That's as much as we have to do. So the hardest part was finding r and knowing what's what over what. After that, it's fairly straightforward. See what's next. Okay, so here we have a concept of a common quadrangle. Okay, I think I skipped this. I didn't put this in your all's notes, so we'll just don't have to worry about that one. I don't think it's all that important. The book thought it was. All right. It says find the exact value of cosine of pi if not defined, write undefined. Okay. Cosine of pi. So here I am, cosine of pi. So this is from my unit circle. I have to know what my unit circle was. Cosine of pi. You have to realize that, oh, hey, pi is over here. All right? It's all the way around. So pi, there's my angle of pi, which is 180 degrees. So on your unit circle, take a look. What is that coordinate right there? That coordinate right there is -1, 0. My radius is 1, right? So what is cosine? Cosine, we go back to what it was. Cosine of pi, again, is equal to x over r. What's the x coordinate? -1. What was my radius? 1. So it's just equal to -1. There it is. Okay. So let's go with next. Now I ask you to find tangent of 450 degrees. If not defined, write undefined. Okay. So here I go. I'm going to do my same, what we did before. Here's my thing. 450 degrees means I'm starting here. I go all the way around to 360. 450 is another 90 degrees. So there's 450 degrees. We'll use that same thing. We'll use my unit circle. My unit circle says, hey, what's that coordinate right there? That's 0, 1 of 400. Okay, so there's my. I want to find tangent of 450 degrees. Well, tangent of 450 degrees. Again, what's tangent? Tangent's going to be y over x. When I get to y over x, I go ahead and plug this in. 1 over 0. Where did I get that y over x? Look at the first slide, or the very top of your front page. That's where I got it from. Okay, 1 over 0. Wait, can I divide by 0? No, so that means I am undefined. Hopefully you can see how these examples are working and how I'm doing them. I'm taking the information and doing, just building it one step at a time. Find the exact value of cotangent of 7 pi over 2. So again, draw this out. I do 7 pi over 2. Here we go. 1 pi over 2, 2 pi, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. I grab my unit circle. I find out, hey, where is this at? My unit circle tells me this is at -1, 0. I go up to the top and I realize what is tangent. Not tangent this time. We're not dealing with tangent. We're dealing with cotangent of 7 pi over 2 is equal to, this time if you look up at cotangent, it's y over x. So this time I do y over x, 0 over negative 1, which is equal to just old 0. Whew. It's amazing what you can find out with a circle and a whole bunch of degrees. All right? Let's keep going, see what we get to next. Okay, so we talked about reference angles before. Reference angles are very important. Okay, reference angles will help me determine what, as far as it'd be like saying, where to look in my unit circle. So I'm able to figure out, if I can figure out what the reference angle is, I can figure out what to look for in my first quadrant. Okay, and if you didn't understand what reference angles were before, reference angles are the angle from the terminal side to the x-axis. So this is your reference angle. On this one here in quadrant 2, terminal side, here's your reference angle. Here's my angle that reached all the way over to quadrant 3. My reference angle again is between the terminal side and the x-axis, right here. When I'm in quadrant 4, here's my reference angle. Okay, and they give you some kind of handy different ways of trying to find out what's your reference angle really quickly. All right, so here we go. See if we can figure some examples out. It says find the reference angle. So first thing I want me to do is sketch at negative 150 degrees and find its reference angle. In fact, what I want you guys to do right now is I want you to pause me. All right, I want you to do this. Sketch at negative 150 degrees. You should be able to do this and find its reference angle. Boom, there's my answer, 30 degrees. All right, so let's talk about how I got this. There's different ways you can do it. What I found out was that, okay, negative 150 degrees. I don't know. I don't deal with negative numbers. So I want to make this into a positive number. So I found the coterminal side. Right? Coterminal means that negative 150 degrees is the same as a positive 210 degrees. That's why I added the 360 full time around. Okay, it got me to 210 degrees. Then I used the nice little chart that I showed you above. Well, I'm in quadrant 3, so I subtract 180 degrees, and that gets me my 30 degrees, and that's my reference angle is 30 degrees. Okay. That may have seemed a lot. You may have just noticed that, hey, this is negative 150. I got 30 more degrees to go before negative 180. My reference angle is 30 degrees. I'm cool with that too. There's many ways to do this. Okay? Let's see what we got going on now. Sketch 3 pi over 4. All right. And find its reference angle. So here I am, 3 pi over 4. If you need help sketching 3 pi over 4, go grab your unit circle. See how handy it is? I know there's 1 pi over 4, 2 pi over 4, 3 pi over 4. There's 3 pi over 4 right there. And they want to know, find its reference angle. Well, again, I use the handy-dandy chart they have up there. I'm in quadrant 2. It says 3 pi over 4. I'm going to subtract 1 whole pi. So 3/4 of a pi minus a pi is equal to 1/4 of a pi. Pi over 4. And sure enough, that's my reference angle right there. Okay. Next, let's go ahead and do this. See what's next. All right. Now we're getting to the nitty-gritty. This is going to be hardcore stuff. You ready? Okay. So it says here, find the reference angle. So if I want, what the next thing to do is, okay, I have all these trig values available to me through my unit circle. How can I find the value of any of those nice things really kind of quickly? And not just going, guess, Okay. One of the ways that we can do this is through our reference angle. And you need to know your reference angle, because as soon as you figure out your reference angle, it's going to help you with the first quadrant. Again, this may sound kind of odd coming from me since we haven't done any examples, but we're going to do some examples and it should make hopefully more sense as we go through it. Once we find that reference angle, you're going to find the value of the trigonomic function, and then we're going to know which quadrant it is in the terminal side of theta lies to determine the sign of the trigonomic function. So let's get going. These 3 steps are crucial. So find the exact value of sine of 4 pi over 3. So I come over here and find the exact value of sine of 4 pi over 3. Again, if I need some help, I'm going to sketch my little graph here. Okay. 1 pi over 3, 2 pi over 3. Wait. 1 pi over 3 was here. It's 1/3, 2/3, 3/3 is 3 pi over 3 is 1, and then 4 pi over 3. Okay. So here I am, 4 pi over 3. What's my reference angle? So again, I do this. So first step, find my reference angle. I'm in quadrant 3. Quadrant 3 says since I'm all the way over, my reference angle is right here, so the thing I can do is get rid of 1 whole pi. So I'm at 4/3, 4 pi over 3. I'm going to take away 1 whole pi, which is the same as 3 pi over 3, which is then equal to just 1 pi over 3. So my reference angle is pi over 3. Reference angle. Why do I call it my reference angle? Well, because now I want to find out what is my sine of pi over 3. Well, sine of pi over 3, okay, that's we're going to either use your hand method or the way that you know just to memorize these. I find out that sine of pi over 3 is equal to, okay, sine of pi over 3 is equal to square root of 3 over 2. All right, great. But what about, I don't want sine of pi over 3, I want sine of 4 pi over 3. Well, this is where, again, I've got to use some of my more stuff that I know about the trig, but the unit circle. I know that I talked about saying that my unit circle said that all students take calculus, tell me which ones are positive. And I look at 4 pi over 3 is in my quadrant 4. The only ones that are positive are tangent. Is sine tangent? No. So sine is going to be negative. So here's what I know. I know that sine of 4 pi over 3 is going to be the negative version of sine of pi over 3, which means that that's going to equal a negative square root of 3 over 2. Oops, yeah, circle the whole thing. That's your whole answer. Okay. And you didn't have to memorize what was all over here. You just had to know this and what was this going on over here. Okay. Next. Let's find the exact value of tangent of 150 degrees. All right. Tangent of 150 degrees. So again, I can help myself out here, kind of gauge what this is. I know that this is 150. There's 150 degrees. Oh, I'm in quadrant 2. Good. And I find out, oh, what's my reference angle? My reference angle is, again, 30 degrees. All right. So that means that my reference angle is 30 degrees. So that means in order to work on tangent of 150, I do tangent of 30 degrees first. All right. Well, tangent of 30 degrees, well, that's just the y over x of 30 degrees. So again, you can look at your unit circle, find out what are my values there for y over x, or use your method of memorizing. Okay, 30 degrees. All right, and I find out that it's going to be 1/2 over square root of 3 over 2. Which then if I go ahead and plug this in, or not plug this in, but rewrite it as 1/2 times 2 over the square root of 3. You got to remember how to do this, okay? The algebra says keep the top, flip the bottom, change it to multiply. 1 times 2 gets me 2. 2 times square root of 3 gets me 2 square roots of 3, which is just 1 over square root of 3. Now, normally I would say, yes, that's a perfectly great answer. But again, remember, we don't like doing that. It's not always pleasant. That may not be the way that the book has it or the answers have it. So I'm okay with, you got to know how to change the square root out of the denominator. 1 times square root of 3 is square root of 3. Square root of 3 times square root of 3, square root of 9, which is 3. That's for tangent of 30. Again, I don't want tangent of 30. I want tangent of 150. So again, I break that nice mnemonic out of all students take calculus. S stands for sine, so sine is the only one that's positive in that one. Is tangent sine? No. So that means that tangent of 150 degrees is equal to a negative tangent at 30 degrees, which means that this is going to be a negative square root of 3 over 3. I know, it's a lot. Breathe in, breathe out. Okay. So next, I come over here. Let's find out what's next. Find the exact value of secant 15 pi over 4. Here we go. So here we go again. Secant of 15 pi over 4. Here's what I know. There are 8 pi's over 4. So there's 8 pi, 9, 10 pi, 11 pi, 12 pi over 4, 13 pi over 4, 14 pi over 4, 15 pi over 4. There is 15 pi over 4. What's my reference angle? Hey, it's this right here. I'm going to cheat. I know what my reference angle is. Pi over 4. That's what's left over to get there, because it's 16 pi over 4 to get up one more. Okay, so my reference angle is pi over 4. So now I can go ahead and find out what secant of pi over 4 is. And you're going, oh my God, what is secant of pi over 4? Okay, well, what's the relationship between secant and cosine? You have to remember that secant is equal to 1 over cosine of pi over 4. They're reciprocals of each other. They can, so given that, again, pi over 4, that's my 45 degree one. Okay, this is going to be equal to 1 over square root of 2 over 2, which again, this means is 1 times 2 over square root of 2, which I don't like that square root of 2 on the bottom. Which then this is 2 times square root of 2 over 2 times 2, which is, square root 2 times the square root of 2, which is square root of 4, which is just 2. The 2's cancel. You're left with just square root of 2. Great. Is that what I'm looking for? No. I got to use my same phrase again. All students take calculus. All students take calculus. So I'm in the quadrant 4. Cosine is the only one that's positive. Hey, cosine and secant. That's the ones I want. They're going to stay positive. Okay, great. So I know that secant of 15 pi over 4 is equal to the same thing as secant of pi over 4, which is then equal to square root of 2. There we go. I know, it's a lot. Here we go. Let's see what's next. All right, example 5. Let secant of square root of 29. And we're sinus, okay, second to last example, we're almost done. Where sine is greater than, sine of theta is greater than 0, find the exact values of the remaining 5 trigonomic functions. So when you're given this, it's like, holy heck, how do I figure this out? Well, go back up to the very beginning. Find out that, what is it, secant of theta is equal to, let's start off here, 29 over 5, which is then equal to, well, secant is the reciprocal of cosine. So this is equal to r over x. Again, just look at the table at the very top with all these stuff in it, r over x. Well, wait, what does that mean? Okay. Well, that means that x is a positive 5, and r is a square root of 29. And the question then becomes, so here's x is a positive 5, square root of 29, dink, right up here. What's that value going to be? All right, so let's go find that out. How can I find that out? Pythagorean theorem. I know that, there's my y, that my y squared plus 5 squared is equal to square root of 29 squared. Y squared plus 25 is equal to 29. Subtract to 25, take the square root. Y is equal to 2. There it is. So y is equal to 2. Now I can go get my other ones. I can find out that sine is equal to y over r, which is then equal to 2 over square root of 29. Cosine of theta is equal to x over r, which is equal to 5 over the square root of 29. And tangent of theta is equal to y over x, which is equal to 2 over 5. And you can get the other two from there. The other two are cosecant of theta, which is r over y, and cotangent of theta, which is x over y. I'm not going to do it. We're getting too long. In fact, I'm not even going to do the last example. All right? This should get you enough of what you need. See you guys on Monday. Bye.